The story of our universe began nearly 14 billion years ago with the Big Bang. For the first 300,000 years or so, the universe was a hot fog of energy and seething plasma that light couldn't penetrate, known as the Cosmic Dark Age. But then, over the next billion years, as the universe expanded and cooled, new galaxies, planets, and stars were formed. Now, with the help of James Webb in space, we will finally be able to discover how our universe came into existence. Hey everyone, welcome to Space Scientists. In today's video, we are going to talk about terrifying new discoveries made by James Webb, and why the first images of the Big Bang will rewrite physics. So if you want to know more about it, then stay with us until the end of the video. And before we start the video, don't forget to like this video, subscribe to our channel, and ring the bell icon for more amazing videos. Everything about James Webb Space Telescope, from its conception to its launch, has been nerve-wracking for the scientists. After the successful launch on Christmas from Arianespace's ELA-3 launch complex at Europe's spaceport located near Kourou, French Guiana, many thought that the most difficult part had been done. But that was just the beginning. First light is an important milestone for any telescope, as it is the point where starlight is detected by the observatory and its various instruments. Through this, the observers can enable a months-long alignment of the telescope. Webb's first light came from a star known as HD 84406. It is a sun-like star and is located 241 light-years from Earth, and part of the constellation Ursa Major, the Great Bear. Now, if you think what Webb has started taking pictures and began a new era of space observations, then that's not the case. These images are not going to be used for research purposes. Rather, they are going to help Webb's mission control team to align the 18 golden segments of the telescope's 21-foot wide main mirror. So these images are not the way we expected the telescope to show us, but it's exactly what NASA had expected, and over time, it will be able to adjust to segments to bring the image into focus. John Mather, a Nobel laureate and astrophysicist who also works at NASA Goddard Space Flight Center in Greenbelt, Maryland, said, "First, we have to find the images that all of those 18 different hexagons are making, then figure out which one is which, and then start sending commands to the little motors that move the viewers around to get them in the right place." The Webb is the vaunted bigger and more powerful successor to the Hubble Space Telescope, and astronomers expect that it will pierce a dark curtain of ignorance and supposition about the early days of the universe and allow them to snoop on nearby exoplanets. However, perhaps the most important question about the universe for much of the 20th century was whether it had a beginning or if it has always been this way. This first snapshot of what the early universe looked like 400,000 years after the Big Bang was taken in the 1990s using NASA's Cosmic Background Explorer satellite. The scientists who led the work were awarded a Nobel Prize in Physics in 2006. According to Dr. Mather, JWST's senior project scientist, "I'm hoping that it will tell us about the beginning of everything. If all we do is confirm the story we've already got, that would be interesting. But I think it's also possible there's something that we haven't guessed out there yet to be discovered." Webb's predecessor, the Hubble telescope, has meant so much during its 30-year run, as it has sent us unforgettable, jaw-droppingly beautiful images like those of the Lagoon Nebula and the Pillars of Creation. It's also taught us about the age of the universe, about what happens when stars explode, about black holes, helping us build boundaries which the Webb will push forward. Most powerfully, its observations have led scientists to believe the universe is expanding at an accelerating rate, propelled by something so mysterious that scientists simply call it dark energy. On the other hand, the Webb telescope is named after James Webb, the man who led NASA in the decade leading up to the moon landing. The technological achievement of the NASA's new telescope is going to be unconventional because it is set to take the success of the Hubble one step ahead. Amber Strawn, an astrophysicist at NASA who works on the Webb, has stated that what we're going to get is a telescope that's about 100 times more powerful than Hubble. But the question is, how will the Webb outperform Hubble? The Webb has two major advantages over Hubble, and the first one is its size. Hubble was about the size of a school bus, but the Webb, on the other hand, is more like the size of a tennis court. Strawn has also praised its size and said, "This thing is enormous. Webb is by far the biggest telescope NASA's ever attempted to send to space." However, it's not the size which is going to make the Webb extraordinary. When it comes to reflecting telescopes, the key component is the size of the curved mirror. The more light you can collect in this bucket, the fainter and farther away you can see in the universe. Hubble's mirror was an impressive 7.8 feet in diameter, and comparably, Webb's beautiful gold-hued mirrors combine for a diameter of 21.3 feet, which overall amounts to more than 6 times the light collecting area. To put it in simple words, let's consider one of Hubble's most famous images, the Deep Field. In 1995, scientists set the Hubble to stare off into a teeny-tiny patch of sky and capture as much of the light as it could from that one spot. As a result of this, Hubble uncovered thousands of galaxies in this teensy patch of sky, helping us refine the number of galaxies thought to exist in the universe. It was not just an image, but it also helped reveal Hubble's power to act as a time machine, because in astronomy, the farther the things are, the older they are. Therefore, Austin Casey, an assistant professor of astronomy at the University of Texas at Austin, is very confident about the performance of the Webb in this regard, as she has stated. What Webb will do is to take that field and go even further. So the tiny specks of light in the background of the Hubble Deep Field will brighten and become more detailed. We'll be able to see spiral arms, we'll be able to see structure, and then we'll get more specks of light even further in the past. And this is it for today. What are your thoughts on today's video? Share your views with us in the comments below. Also, don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.